So here we're talking about our flow chart for quadrilaterals, and then we're going to go through the properties. So one type of quadrilateral is a parallelogram. We did our properties of parallelograms. How are we able to identify if something is a parallelogram? We know what?
It's closed.
So that's how we know if it's going to be a polygon.
Two opposite. Is that right?
You're on the right track.
Opposite sides.
Okay, so we see that opposite sides are congruent. So both pairs of opposite sides are congruent. We know something else about both pairs of sides. What's our other thing we know about both pairs of sides?
They equal.
They're not necessarily equal. That's what you're talking about in the first one, that they're congruent. That they are parallel. Both pairs of opposite sides are parallel. Remember, we can do parallel by those really big, looks like ones or L's. What else do we know about our parallelogram? Yep, Lanaya?
Shouldn't one of the sides be separate?
Can you say it a little louder?
Shouldn't one of the sides be separate?
Ooh, not sides, but what? It's not sides, it's angles. So we know that, how do we want to say that? Consecutive angles are sup. And remember, supplementary means adds to 180. Okay, so now we are at Dion and Bree. So we have we have two properties left. One is about diagonals and one is about angles. Which one would you like to do? So we see that the diagonals are bisected, is what Dion told us. Diagonals are bisected. Okay, and then Gryffindor, the three of you, have the answer to the question about opposite angles. We know what about opposite angles? Yep, opposite angles are congruent. Okay, so this is parallelograms. And then we have two subgroups about parallelograms. We have rectangles and we have rhombus. So if we go to the properties of rectangles. So we are now over here at Slytherin. We have two properties of rectangles. You can choose which one you want to tell us. Yeah, Mario.
All sides No.
So not sides, all
Angles.
Yep, so you have 4 right angles. Yeah, Gabby. So we know that our diagonals are congruent. Okay, back to Bree and Dion. You see we have properties of rhombus. What are your 3 properties of rhombus? Of a rhombus, probably sounds better.
Opposite sides are congruent.
We know something a little more specific.
All sides?
We know all sides are congruent. Okay, so that brings me back to Gryffindor. What else do we know about? You can pick, both of them are about diagonals. Yep, each diagonal is a perpendicular bisector. Okay, and our last one is also about diagonals. So that's Slytherin. What do you know? Number 3 on the rhombus, third property.
Bisects the pair of opposite angles.
So each diagonal bisects a pair of opposite angles. Okay. Okay, now that we have this, we have the other half of quadrilaterals, which we're going to be talking about is trapezoids. So we have two properties of trapezoids. So we're now back at Hufflepuff. Hufflepuff, what is one of the properties of a trapezoid? Okay, so over here, Brandon already told us the answer to this question. And he told us that the median is parallel to the bases. So the median is parallel to the bases. And what goes along with this is that means you have one pair of parallel sides. One pair of parallel sides. Okay, along with that, we also have one more property, which is for Bree and Dion. And I know Dion was not here yesterday.
Whoa.
Bree and Dion.
Yep, it's your turn, girl.
Okay. Okay, so here we have a trapezoid. And this is, we see that same side, interior angles. Angles are sup. So they are supplementary, adding to 180 degrees. Okay, so now we're on isosceles, and Bree, you had one of those. What'd you have?
The lower base angles are congruent.
Lower base angles. Yep.
You ever use this? Please. Look at her smell. Yeah.
Okay, so what else do we know? So that brings us to Gryffindor. What's another property? So Malik or Mikhail? So upper base angles are congruent? Okay, our next one is Slytherin. So what do you know about, we have two other properties. One's about diagonals and one is about the angles again.
Did you skip it?
Hmm?
Did you skip it?
Bree answered it. First one is Kevin. So one is about the diagonals and the other one is a... So the diagonals are congruent.
Is that an L?
Angles. Okay. And we go back over here to Hufflepuff. And what is your last one here? It's about a relationship between the base angles and the upper angles. The lower and upper angles. They're not all congruent,
Two of them are congruent.
which we already covered in the first two.
Either upper base
Either upper base
angles.
are congruent.
Which we already said. So that's not what we're looking for.
Are
Opposite.
Hold on.
sub to the base.
It is supplementary to
To upper ankle.
either. Yeah, but it's okay. You said in reverse. 6.6 warm-up or bell ringer. A quadrilateral that is both a rhombus and a rectangle. So if you use that sheet we just had, what is a quadrilateral that's both a rhombus and a rectangle? Hold on. It is Ravenclaw. So both a rhombus and a rectangle.
Oh my gosh.
Is it a square?
That is a square. A square is both a rhombus and a rectangle. A square. Okay, which is a quadrilateral with both pairs of opposite sides that are parallel? It's going to be a parallelogram. Now we know that there are other shapes that are more specific, but based on this definition, we can't pick the more specific ones because we don't have those as clues. On number 3, we are over here at Slytherin. It is a quadrilateral with exactly one pair of parallel sides. So we're going to say trapezoid because we don't know for sure if it's isosceles, but the trapezoid. Thank you. So we have a trapezoid, and our last one, we're back over here at Hufflepuff. So any parallelogram with perpendicular diagonals.
A square.
Not necessarily just a square.
Can't pop it.
We see here we have a rhombus. So we've talked about this before. When you're proving that a quadrilateral is a parallelogram, these are some of the things you might want to prove. That both pairs of opposite sides are parallel, that both pairs of opposite sides are congruent, that both pairs of opposite angles are congruent, that the diagonals bisect each other, and that one pair of opposite sides is both parallel and congruent. So if we're going to prove a parallelogram is a rhombus, we must show that it has 4 congruent sides or that the diagonals are perpendicular. If we are going to prove that a parallelogram is a rectangle, we must prove that it has 4 right angles and that the diagonals are congruent. So if we're going to prove that a parallelogram is a square, we show that it's a rectangle with 4 congruent sides. And we also could show that it's a rhombus with 4 right angles. Or we can show that the diagonals are both perpendicular and congruent. Okay, so we just talked about the properties of proving a parallelogram is a square, and now we're going on to our examples. So you're going to have to draw a few things in just like I do. So our first part here is we have to add our diagonals in the first one. So diagonal 1, diagonal 2, and we are going to name our shape. So we see that this is A, B, C, D, E, nope. Okay, and then I'm going to add the ones into the next one so you can see those as well. Can you give me 1 second, hon, and I'll listen to what you just said?
Who?
You.
Me? I said it before.
Must each quadrilateral be a parallelogram? So our first one, do we know this is a parallelogram, yes or no? And this question goes for Dion and for Bree. So is this a quadrilateral? Is this quadrilateral a parallelogram, yes or no?
Yes.
It is, and how did you know that? So we don't necessarily know about the sides being parallel. There's nothing on our picture to show that. But what do we...
The diagonals are parallel.
So not necessarily, they're bisected. So we see that our diagonals are bisected.
What about saying again?
So anybody tell me what bisected means?
Cuts in half evenly.
Cuts in half evenly, yep.
Is that what BC means?
B/C is because, shorthand for because.
No.
Mikhail already told us the answer is.
No.
And how did you know it's no? Opposite angles aren't what? Are not congruent. Instead of writing are not congruent, I could have written the congruent sign with the slash through it. So ABC is a quadrilateral. Give the most specific name. So question A. For all of these, I'm just going to pull them up because you guys have them on your page. I drew a general shape for this. It not necessarily is how it's supposed to look, but just so I could see it. So we see that this is A, B, C, and D. We see that this and this are my diagonals. Okay, so if we are doing question A, and we see that A, B, and C, D are parallel, and they are also equal, which means that they are congruent, what shape do you have?
Rectangle.
So do we have anything in there that would describe
I
a
mean,
rectangle?
the trapezoid.
So let's look at our page and see what we can do instead of just guessing. So maybe I'll do this one and let you guys do the next one. So when you see that you have parallel sides and those same sides are congruent, based on those two facts, it has to be a parallelogram.
I said that.
Stop lying.
Okay, please behave, guys.
We all behave.
Okay, our second one, we'll go back to Slytherin for this one. We see that AC and BD bisect each other, and AC and BD are congruent or equal. So we see that your diagonals are bisecting each other and that they're congruent. Which shape has congruent diagonals?
Okay.
It is a rectangle. Nice save. So we see we have a rectangle for B. Okay, our next one, we have number C, which goes back over here to Hufflepuff. We see that AC is perpendicular to BD, and we see that AC and BD bisect each other. Which shape does that describe? So you see that you have your diagonals being perpendicular, and they're being, yep, it's a rhombus. Oops. Rhombus. So we are now back at Ravenclaw. When you have AC perpendicular to BD, what do we have? So perpendicular diagonals.
All sides are the same.
So that, for this one, what is it going to be?
Rhombus.
It's going to be a rhombus again. Okay. Gryffindor, you're up. You see that AB equals BC, which equals CD, which equals DA. So you see here that all your sides have the same size. So do rectangles necessarily have all the same size sides? All congruent sides? It's a rhombus again. We see again that it's a rhombus because all the sides are congruent. And last but not least, we're over here at Slytherin. So Slytherin, you see that AC and BD bisect each other. AC is perpendicular to BC, and that AD is perpendicular to BA. So it's going to be a square. Nice job.
No, I didn't. I looked at the paper.
Okay, so we're back at proofs. Remember, you create your chart, statements and reasons. You number your steps. Your first step is always what's given. So my first step is that we see that W, X, Y, Z is a parallelogram. And we know this because it is given. So since this is a parallelogram, let's look at what we're setting out to prove. Well, we want to prove that WX and YZ are congruent. And we want to prove that WZ and XY are congruent. What property is that? So if you look on the fact that we know that parallelograms, what do we have in there? Yeah, both pairs of opposite sides are congruent. So you're done with this one by saying what it told you to prove. So 2, WX is congruent to ZY, and WZ is congruent to XY. And we know this because two pairs of opposite sides, or both pairs of opposite sides, are congruent of a parallelogram. Are congruent. And this is because it's a property of a parallelogram. So we know, and we have updated our picture so that we can have it. We want to create our table. Remember, this is the first part, statements, reasons. Okay, so step 1, state what was given. So we see that AO is congruent to CO, and we see that BO is congruent to DO. I already drew those onto our shape, so we're able to see that. And we know that that is given. So 1 is given. So with this, we are able to see, since those are cut in half, what has happened. What happened to these diagonals? They've been bisected. So we can say that BD and AC have been bisected by the definition of a bisector. So step 2, AD and BC have been bisected. Are bisected. And this is by the definition of bisector. Okay, our third step is saying what we know. We know that ABCD is a parallelogram. And we know this because of what? By the property that diagonals of a parallelogram bisect each other.